Hello everyone, my name is Mete Atamel, and today I'm going to talk about resilient microservices with Kubernetes. First of all, thanks for being here this early. Um, if you're careful enough, you'll realize that I cheated a little bit. I changed the title because the title, if you look at the agenda, says resilient Java-based microservices. But then I realized that as I was putting the presentation together, all the stuff that I'm talking about, it really applies to any kind of microservice. So it doesn't have to be Java-based. When you're working with Kubernetes, you're working with containers. And with containers, as long as you have it in a container, it doesn't matter what it is. So that's why I changed the title a little bit, because I'm going to talk about microservices in general. And actually, the microservice that I'm going to show you, it's based on .NET Core, which is kind of interesting. So let's get started. First, a little bit of information about myself. I'm a developer advocate for Google. I'm based in London. My name is Mete Atamel, and this is my Twitter, my email, and my blog. So if you have any questions about any of the stuff I say today, feel free to reach out to me. I'm also going to publish the slides at my Twitter account. So if you want to get these slides, just follow me and I'll put them there. So the agenda today is first, before I start talking about containers and Kubernetes, I want to do an introduction. I want to talk about the monolith applications and what was wrong with them. I'm going to talk about breaking monolith into microservices and how that helped. And then we're going to get into containers because microservices, they're not the solution by themselves. So my containers help in that space. We'll look at what they are and how they help. But containers themselves, they're not the solution because you still need to manage them. So that's why we have Kubernetes, tools like Kubernetes. So I'll talk about what is Kubernetes, how does it help, and then finally we'll get into the building blocks of Kubernetes. So we'll talk about deployments, pods, labels, selectors. There's a lot there. I'll see how much I can cover, but if I cannot cover everything, you're going to have my slides, and I'm going to be here for the rest of the day as well. So if you have any questions, you can get to me. All right? So let's start talking about the monolith. So what is the monolith? Depending on who you talk to, you get different answers to this question. But in my mind, this is kind of like the simplified definition of what a monolith application looks like. So you have a bunch of modules. They have some kind of dependencies. But these dependencies, like they call each other directly, so they're not calling each other through public APIs. They depend on each other directly. They are probably sharing a common state, so it can be a database, or it can be a NoSQL database, or data store, something like that. But they're all sharing that. And then the worst thing is that these modules, even though they are separate, we take all this time and effort to create separate modules. But when we deploy them, we bundle everything together and deploy them all at once to an app server or web server or something like that. So in the Java world, you can think of modules as the web applications. They're bundled into WAR files, and then you put together these WAR files into what's called an enterprise application, which is an EAR file. So you bundle everything into an EAR file, and then you deploy that EAR file to your app server all at once. Now, obviously, this has lots of problems, and these are some of the problems. First of all, you have the unnecessary coupling among modules. You can, since you're bundling everything together, you can update the whole thing, or you don't update anything at all. And this is really bad because if you have teams working on one of the modules, and then you have another team working on the other module, you need to kind of wait for each other and integrate and create this single bundle to update everything. It's hard to scale independent parts. So let's say your front-end module needs to scale much more than the back-end because the front-end has to handle lots of load. It's hard to do that when everything is bundled together. It's very hard to establish ownership. So I worked at places where every team owns a module. That's great. They feel the ownership for the module, but then who owns the whole thing? Who owns the integration? What happens is that the teams they feel like someone else owns that. In the end, no one owns it, and then you have people blaming each other when things fail. And then it can be hard to debug and test this whole monolith application. And the reason is that again, each module can be easy to debug and run on your laptop. But when you bundle everything together, it becomes really big, and then it becomes really hard to run that on your laptop. I actually worked at a place once where we just couldn't run the whole application on a laptop, so there was no way we could test end-to-end and debug on my laptop. So we realized that monolith applications, they weren't great, so we started in the last 2 or 3 years breaking monolith into what's called microservices. So every conference you go to, you will hear like a number of talks on microservices, including this one. So that's what I'm going to talk about too, but then we're going to switch to containers and Kubernetes very soon. So what is a microservice? Again, depending on who you talk to, you get different definitions. But my definition is that first, a microservice has to be small. It has to do one thing. I think it's not realistic that it does one thing. It probably does like a number of things, but the scope is really small. So that's number one. And then it has to be maintainable by a small development team. So a developer of like 4 or 5 people should be able to maintain and run a microservice on their own without having to need anyone else. So it's small. It has its own data store. This is really important because no matter how you break your application, if they depend on the same backend, in the end it doesn't matter. You're still tightly coupled. So each microservice, they have to have their own data store. And they have to define well-defined public APIs. So each microservice, they define a public API that other microservices can call. So in this case, for example, we can have 3 microservices. They each do one or few things really well. They each have their own data store. They each define their own public APIs. And these microservices, they still call each other, because they need each other. And that's what our application is. And that's okay, because they're calling each other through public APIs. They're not calling each other directly. So when this dependency is through public APIs, it makes the dependency between microservices much more official and much more explicit. This way, you know what your dependencies are, and then if you need to change something within the microservice, you can do that as long as you don't change the public API. If you need to change the public APIs, it's okay. It's best practice to version your public APIs, so you can have version 1, and then if you need to create a new version, you can have version 2, and you can still support the old microservices calling version 1, and then the new microservices calling version 2. And then your application becomes this logical thing. So these microservices, they're independent, they're deployed independently, they're run independently, maybe they're on the same machine, maybe they're on different machines, but your application, but they're not deployed, they're not bundled together and deployed as a unit. So your application is this, some of these microservices, it's a logical thing, it's not one package like an EAR file. All right? Now, microservices, they help with some of the problems that we talked about with monolith. We can scale things independently, we can update things independently, teams can iterate at their own pace, stuff like that. But now you have a new set of problems. First, instead of worrying about one big thing, now you need to worry about 50 small things, and that can be challenging. Debugging and testing can still be challenging because debugging a single microservice is probably easy, but then usually when a request comes in from a client, it goes through a microservice one, and then it goes through another microservice and another microservice. And these microservices, they can be on same machine, they can be on different machines. If you don't have proper logging and instrumentation, then it becomes really difficult to trace where the request is going and where things are failing. So you need to make sure that you have proper logging, proper instrumentation, things like that, so that you can track when a request comes in. You usually use like a request ID when the request comes in, and then you propagate that ID through different microservices. So that's how you can keep track. So we have this infamous problem in software engineering called "it works on my machine." So you run a service on your machine, it works great. Then you deploy it to production, it doesn't work, and you don't know why. Actually, you know why. The environment on your laptop is different than the environment in the production. No matter how hard you try, it's going to be slightly different, and then sometimes this can cause problems. So microservices, they don't help with this. You still have this problem. And then most importantly, all the common problems about running services in production, they still apply. So if you want redundant services, you need to have multiple copies of your microservice. If you want resilience, you need to watch for microservices, and if your microservice dies, you need to start a new microservice. No one is going to do that for you. You have to do that yourself. If you need to upgrade your code, you need to do that in a consistent way. If during the upgrade something goes wrong, you need to downgrade. So you need to do that in a consistent way. If you need to scale up a microservice, you need to plan and do that. If you need to scale down because the load went away, you need to you need to do that. So all these problems, they still apply. So even though we took our monolith, broke it into microservices, we still have all these problems that we need to deal with. So that's when containers and Kubernetes comes in. But before I show that, I want to start with a demo. I want to create a simple microservice. It's going to be very simple, and then we're going to use this microservice later to containerize it and to run it on Kubernetes. I was going to do this live, but then yesterday I realized that the Wi-Fi is not that great. I'm not sure how it is today. I haven't tried. So what I did is I went back to my hotel and I actually created videos of these demos to make sure, because I really wanted to show you this stuff. So I created a video, and that's what I'm going to show today. So I apologize that it's not live, but it's almost as good as live, I hope. So what I'm going to do here is, I have this video. And let me just stop this for a second. I'm going to use Google Cloud. And Google Cloud has something called Cloud Shell. It's basically a Linux shell running in the cloud. And then the good thing about this is that you can run it from the browser. So from the browser, you have access to a Linux shell. And I'm just going to use that. And what I'm going to do, as for fun, is I'm going to create a .NET Core application. Any .NET developers here? I mean, I know this is a Java conference. Yeah, there's one guy. Good. The reason why I want to do .NET Core is because, first of all, it's still mind-boggling for me that you can run .NET on Linux now. Like, we are living in a crazy world now, and you can actually run .NET on Linux, and I'm going to show you that. The second thing is I want to show you that Kubernetes basically cares about a container. It doesn't really care whether you're running Java or whether you're running .NET or Python, whatever. So I just want to point that out by running a .NET Core application. So let's do that. Let me make this full screen. So what I'm doing here is I'm starting the Cloud Shell. So this is a Linux shell running in the cloud. I can access it from my browser. And this shell has tools. You have your home space in this shell. And then you also have all the tools installed by default. One of those tools is called .NET. .NET is a command line tool that you can use to create .NET applications on Linux. And you can also use .NET to run your application. So what I'm doing here is, first I'm creating a folder for my application. We'll call it like Hello World ASP.NET Core. And then we'll cd into that folder. And then we're going to create a skeleton.NET application. So we're going to say .NET new -t web. So this will create a web application, a Hello World web application in this folder. So if you look at it, we already have all these files already created for us. What I'm going to do is I'm going to edit the program.js. So this is like the main entry point to my application. It creates a pipeline for my service. What I'm going to do is I'm going to make sure that my pipeline starts on port 8080. So I'm just going to add use URLs, HTTP, and then star 8080. So this will make sure that my application, when it sets up the pipeline, it listens on port 8080. And then we're going to do .NET restore. So my app has some dependencies, and it will basically, by doing .NET restore, you're getting the dependencies from NuGet. NuGet is the package manager of the .NET world. It's kind of like Maven. So this will go and look at all my dependencies in my project.json, and then it will download all the dependencies. So once these are downloaded, I can do .NET run and run my application here in this Linux box, and we'll take a look afterwards. So we will do .NET run. So this will compile and run. And then once it's running, we'll just use the web preview of Google Cloud to actually preview what's running on this Linux box in the browser. So we are doing that right now. So this is the app. It's very simple. It's like an ASP.NET MVC app with some default screens. And that's it. This is the microservice. So we're going to use this later to actually containerize it and then to make it run on Kubernetes, okay? So let me just go back to my presentation. All right. So let's talk about containers now. What is a container? Again, depending on who you talk to, you get different definitions to this question. But for me, a container is a lightweight way of virtualizing applications, okay? At this point, you might be wondering, we already have a way to virtualize operating system. We have virtual machines, right? So we can use that to build our applications on top. So why do we have containers? I think the key here is that it's lightweight.
So these are Linux processes. It started with Linux, but Microsoft also made Windows containers now, so you can have Windows-based processes as well. So these are lightweight. They're very easy to start. They are sealed and isolated. So when you have two containers running, they don't interfere with each other because they use what's called namespaces. So they don't, even though they're running on the same kernel, they don't actually interfere with each other. They're really easy to deploy. So it takes seconds to deploy a container rather than minutes or hours with a virtual machine. They're introspectable, meaning you can get into the container, look at what it's running. You can look at the logs, stuff like that. And for me, the most important part is they're composable. So what you can do is you can have images. That's kind of like the definition of your container. And once you have an image, you can build another image on top of that image. So this way you can layer your dependencies on top of each other. And this is really powerful because if you can basically layer all your dependencies on top of each other and build your own image. And you're going to have the exact same environment on your machine and also in production. And I'm going to show all of this later in my demos. Docker is one of the main container platforms, but it's not the only one. There's also another one called Rocket from CoreOS that does pretty much the same thing. And there will probably be more when it comes to container platforms. Now, if you still have the question of why containers, I think this will clarify that. So what we used to have is shared machines before, right? So we used to have a single physical machine with the operating system kernel, and then on top of that we had the libraries, and then on top of that we had our applications running. The problem with this model was that there was no isolation whatsoever. So all the apps use the same kernel, all the apps use this common set of libraries. So if anything changed in the downstream, in the kernel or the libraries, it could potentially break your applications. Now, at some point we decided that this is not good enough, so we created what's called virtual machines. The idea of virtual machines is that on the same physical box, you can run multiple operating systems virtually. So you can have each of your apps, they can have their own kernel, they can have their own libraries. This is good because now your apps are isolated and they're not sharing the kernel, they're not sharing the libraries. But the problem here is that instead of worrying about one kernel and one set of libraries, now we are worrying about multiple kernels, multiple libraries. So it becomes really expensive and inefficient. It becomes really hard to manage this. Now with containers, what you have is a common kernel. So they run on the same kernel. But instead of having virtual machines with their own kernels, you have apps and libraries in a container. So the good thing about this model is that you still have isolation. So the apps, even though they're sharing the kernel, they don't step on each other because they're using different namespaces. And they're not sharing their libraries. Each library belongs to the container within the app. So you get the benefits of the isolation, but they're not as heavy as virtual machines. So you don't have to maintain multiple copies of operating systems. They're much more lightweight, these containers, compared to virtual machines. So that's why we have containers, and that's why they became really popular in the last few years. And containers are a big deal at Google. Even though containers are kind of new in the industry, at Google we've been running containers in the last 12 years or so. And everything at Google runs in a container. So Gmail, web search, Maps, MapReduce, everything. Even the virtual machines in Google Cloud Platform, they're running in containers because we love everything about containers. They're much more secure. They provide isolation, things like that. And this number is probably outdated by now, but we launch over 2 billion containers per week. So you can see the scale of how much we use containers at Google. So containers are great. They help us to create this lightweight, consistent environment that your application need. So that problem that we used to have, where you run it on your laptop, it works, but it doesn't work in production, that goes away because with containers, you create your environment, and then as long as you have Docker running, you're going to have the exact same environment. But it's still not enough. Because all these problems that I talked about, the resiliency, scaling up and down, deploying a new version of your application, rolling back a deployment if something goes wrong, health checks, graceful shutdown, all these problems that you have that you need to deal with in production, you still need to deal with them. So containers, they don't help with these, okay? So let's now take a look at our small microservice we created, and let's try to containerize that using Docker. So I'll go back to my videos. So here I'm in Cloud Shell again, and I'm going to do, first I need to publish my app. Publishing means take my application, take all of its dependencies, and create a single DLL, single file from that. This is good because I'm going to use that single DLL, and I'm going to tell Docker, run this DLL. So it helps basically to get all your dependencies and everything into a single DLL. So now this is getting all the dependencies on my application, and then building it, and then putting it into a single DLL. So once this is done, we're going to create a Docker image. But to create a Docker image, we need to create what's called a Docker file. So Docker file is kind of like a blueprint of an image. So you use Docker file to create images. So we'll create a Docker file next. So once this is done. All right, so I'll go to the publish folder where the DLL is published. So I have a bunch of DLLs, but there's one DLL here that has all the dependencies, and that's what I'm going to use from Docker. So I already have a Docker file that I created before, so I'm just basically copying the Docker file into this folder. So let's just take a look at this file briefly. Let me just pause here for a second. So this is a Docker file. This is the file that defines how my image is going to work. At the beginning, we are saying from Microsoft.NET 101 runtime. So this basically says I'm building on top of Microsoft's .NET 101 runtime image. So remember I told you these Docker images, they're composable. So I'm basically composing on top of this image, which is great. So all the dependencies that I have on .NET, I'm getting that by just having that one line of code basically. So once I have that dependency, I'm saying copy everything in this folder on my machine to app folder in my container, and then set my working directory in the container to app folder, so everything will work from the app folder in my container. I'm exposing port 8080 in my container, and I'm also setting an environment variable called ASP.NET Core URLs. So this environment variable will make sure that my app, my ASP.NET app, will start on port 8080. Okay? And then the last thing is entry point. So this is how the image, how the container will start. So we'll just start with .NET. This is the .NET command. And then hello world ASP.NET Core. So this is the DLL that we published. So it will basically start this DLL. That's what the container will do. So let's do that. So we have the Docker file. Now we need to actually build the image. So to do that, we're going to say docker build. And then we're going to tag our image. So you can give names to your images. In this case, I'm tagging it with gcr.io. That stands for Google Container Registry, because this is where I'm going to push my image. So I'm saying I'm going to tag this with gcr.io. This is .NET Atamel is my project name. And then hello.net is the name of my image. And then v1 is the version number that I want to give to my image. So this will get the dependencies on my image. So it pulled the image from Microsoft.NET, or actually it's pulling it right now. And then once it does that, it will build the other things that I told it. So it will copy my files to app directory, it will expose port 8080, and then it will just call .NET on my DLL. So we'll just wait this to finish. Yeah, now it's going through the steps. So the first step is done, now copying, and then, yeah. So the image is built. And if we do Docker images, we should see our Docker image that we just created, and we should also see our dependency images as well. So let's do that, Docker images. So as you can see, I have two images. The first one is Microsoft.NET. This is the image that I depend on. And then the other one is my own image. So let's run this image. I can do Docker run. -d means run in the background. -p means expose port 8080 on my container to port 8080 on this machine. So everything that happens port 8080 in the container will be exposed to port 8080 on my machine. Now the Docker image is running. So if I do Docker PS, I can see my container ID. And then if I do a web preview, I should see the same application again. But the difference is that it's not running on my box as it is, it's running within a container on my Linux box. So it's the same app. And let's just stop the container. I'll just do docker stop, and this will stop my container. So that's it. So we took our microservice, and we containerized it. Now let's push this image to Google Container Registry. So Google Container Registry, it's a place where you can store images. And the reason why I'm pushing it there is that I'm going to use Kubernetes in Google Cloud because it makes it really easy. So I'm just pushing my image there, and I'm going to use that image later from Kubernetes. So what I did is I used something called gcloud. Gcloud is another command line tool that you can use to talk to Google Cloud. And I'm saying gcloud docker push, and I just point to my image. So this basically takes the image from my Linux box, and then it pushes it to Google Cloud. So we don't have to wait for this, and I'll skip to the slides. But basically, after like a few minutes, our image will be in Google Cloud, and I'm going to use that later. Okay? So let's just close that. All right, so now let's talk about Kubernetes. What is Kubernetes? It's a Greek word. It stands for governor. Just to give you a secret, it's actually Kubernetes in Greek, but I think Americans, they just started calling it Kubernetes, and now everyone calls it Kubernetes. But I'm from Cyprus, so I know a little bit of Greek, so it's supposed to be Kubernetes in case you want to impress someone. But anyway, so what it does is it manages containers clusters. So you have these containers, and with microservices, you're going to have lots of these containers. So it basically helps for you to manage these containers. It's based on an internal system called Borg at Google. So at Google, we've been running containers for a while, and we had this internal system called Borg to manage containers. So the engineers who worked on Borg, they basically looked at it and learned from it, and they said, let's just create a new version of Borg, and let's try to make it open source so other people can use it as well. So that's how Kubernetes came along. So even though it's not Borg per se, it's inspired by Borg, and because of that, it has lots of common constructs between Borg and Kubernetes. The great thing about Kubernetes is that it supports multiple cloud environments, so you can run it on Google Cloud, you can run it on AWS, you can run it on Azure, you can even run it in your own data center. So you're not locked in into a one cloud provider when you're using Kubernetes. And you can even set a cluster that spans multiple clouds. So you can set a Kubernetes cluster that spans Google Cloud and AWS, which is great. It supports multiple container runtimes, so you can use Docker with it, or you can use Rocket as well if you want. And it's 100% open source. So the great thing about Kubernetes is that it basically, once you set up your cluster, you specify which nodes you want your containers to be scheduled. But once you do that, you basically forget about machines. You just manage applications. You schedule pods that I'm going to talk about. And then you let Kubernetes worry about the machine. So it lets you basically focus on your app and not worry about VMs or machines and stuff like that. Okay? At the very high level, this is what it looks like. So you first have a master that manages the cluster. In the master, there's an API server that manages the calls from the users. And the users can talk to the master using an API or a command line interface or a UI. The master has also something called etcd. Etcd is a key value store, highly available key value store that holds the cluster state, basically. There's a scheduler to schedule containers into nodes, and then there's controller to make sure that things are running as they're running. And then you have the nodes where all the containers get deployed. On nodes, you have something called kubelet that basically manages your communication between master and the nodes. So this is what Kubernetes cluster is at the high level. But as a user, you don't really care about all of this. All you care is that there's an API that you can use either through CLI or through the API itself, and you talk to the cluster. You're actually talking to the master, but you don't care. So you just care about this API, and that's what we're going to talk about later. So when you set up a Kubernetes cluster, there are a couple of steps. First, you need to set up the cluster. So this is kind of like the hard part to set it up. But even this part can be much easier. So if you want to use Google Container Engine, then with one command, you can get a cluster set up and get it up and running. So it's very, very easy. But as I mentioned, Kubernetes also runs everywhere. So if you want to set up your own cluster without having to depend on Google Container Engine, you can do that, but you have to follow these steps. So you basically have to first choose a cloud provider, then choose a node OS, then you need to provision machines, then you need to configure networking, you need to start cluster services, you need to manage them. So there's a lot of steps that you need to do, but it's possible. Or you can just use Google Container Engine and with one command get your cluster. So once you get your if you want to use Container Engine, this is how it looks like. So in Cloud Shell that I show you, you create your image from the Docker file. You create your image. We just did that. You push that image to Google Container Registry. We just did that. So once you have that, you use gcloud and tell Google Cloud, can you please create me a Kubernetes cluster with this many nodes, with this machine type. And within two minutes, you're going to have your cluster. And then you use kubectl, this is the command line tool for Kubernetes, and talk to your cluster. So this is how the workflow looks like, and we're gonna look at this in the demo later. So let's just do that. Let's just create a Kubernetes cluster on Container Engine and see how that looks like. So here I am again in Cloud Shell. I push my image to Google Cloud, and let's actually take a look at that, make sure that it's there. So I go to Container Registry, and under there I see something called hello.net. And if you look at there, there's an image with version 1. That's the image that I pushed earlier in my earlier demo. So I have my image ready. Now I can actually create my Kubernetes cluster. So what I'm going to do is I'm going to say gcloud container clusters create. And then I'm just going to give the cluster a name. So I'm just going to call it hello.net cluster. And then I'm going to say number of nodes, 1. So in this case, I'm just using 1 nodes, but you can have 1 or 20, whatever you need. And then you can also specify the machine type of your nodes. So Google Cloud has different machine types. I'm just going to use a standard machine. And then I'm going to make sure that this cluster gets created in Europe West. So I'm specifying a zone. So this is all you need, basically. Just with one command, I'm going to get a Kubernetes cluster running in the cloud. So this will take probably like 2-3 minutes. And then in the end, we're going to have our cluster that we can use to talk to. So let me just fast forward this so we don't have to wait. So at some point, the cluster, Kubernetes cluster, will show up here. So I just want, yeah, as you can see, it's already up here. And then within a couple of minutes, it will be ready to accept calls from you. So that's what it takes to create a cluster on Google Cloud. All right. Now, once you have the cluster, you can use it. So you can run pods and containers. And I'm going to talk about what these are. You can create replica sets. You can create services. You can create volumes. So this is the fun part. And this is the part that you're going to be working on. You don't create clusters every day. Clusters are usually created by like a sysadmin. And once you have the cluster, you can basically just schedule your pods, create replica sets and services and stuff like that. So that's what we're going to talk in the rest of the talk. So let's look at the building blocks. So what is Kubernetes and what does it give you as building blocks for your apps? So at the very high level, this is what a Kubernetes cluster looks like. So first you have, let me just show you here. First you have your containers in some kind of registry. So in our case, we put them in Google Container Registry, but you can put them in some other registry. It doesn't have to be in Google Cloud. And then from there, you create what's called a pod template. So a pod in Kubernetes is basically a single unit that you can schedule. Usually it contains one container, but it can contain multiple containers. Because if you have containers that needs to live together and die together, you can put them in a single pod. Or it can contain volumes. So you create a template for the pod, and then you create what's called a replication controller. So replication controller basically schedules pods. Here, what we are saying is that I want to have 3 replicas. So I want to have 3 pods running with these labels. And the pods will also has labels. And by the way, I'm going to talk about all these concepts shortly. I just want to give you an overview right now. So the replication controller says, we tell the replication controller, create 3 pods with these labels. It does that here. And it basically just puts them on nodes somewhere here, but we don't care which node where. replication controller figures that out. And each pod, as I mentioned, it can run a single container or it can run multiple containers. And then once our pods are running, we want to expose them as a single unit to the cluster and also to the outside world. So for that, we create a service. So a service basically groups pods together, and then the clients talk through the service. So you talk to the service, and then from the service, you get to the pods. And your microservice basically becomes the sum of these. Oops, sorry. So the microservice basically is the sum of your replication controller, your pods, and your service. So that's how it looks like in a containerized world. Okay? So now let's take a look at each of these in detail. First, I want to talk about deployments. So as I mentioned, in Kubernetes, there's like pods and services and replication sets, things like that. So the high-level construct is called deployment. It's a new concept in Kubernetes, and you can think of it as the high-level construct that you create, and under the covers, it creates the pods, it creates the replica states, stuff like that. So you just created a deployment, and then that figures out all the lower-level stuff that it needs to make it run. And I'm going to show you a demo of this shortly, actually right now. So let's just create a deployment first. So everything starts with a deployment in Kubernetes. So we have our Kubernetes cluster already. So as you can see, I'm in Cloud Shell. I have my cluster ready. So now let's just create a deployment in this cluster. So what I'm going to do is I'm going to say kubectl. At first, I need to connect to my cluster. So I need to authenticate basically my Cloud Shell to talk to my cluster. So I did that. And now I can run kubectl commands from my Cloud Shell to Kubernetes. So what I'm going to do is I'm going to say kubectl run and give it a name, hello.net. So that's going to be my name of my deployment. And then I'm just going to point to the image. So I'm pointing to the image that I pushed to Google Cloud. So this will create a deployment called hello.net, and it will create a replica set that will look at that image template, and then from there it will create a pod, and it will run our image, okay? But the deployment basically takes care of all of that for me. So we created the deployment, it was quick. So as you can see, when I do get deployment, I have my deployment already running. And then if I do get pods, my pod is container creating, so it's being created. But if I do get pods again, it's already running. So it's really fast, as you can see. And then if I do get replica sets, I already have a replica set created by deployments. And then if I do services, I don't have a service yet because this pod, I'm not ready to expose it to outside world. I have a Kubernetes service, which is a default service in Kubernetes, but I don't have a service for my pod yet. So we're going to do that later. So as you can see, with deployment, basically, you just create deployment, and then that creates the lower level stuff that you need to run it. Okay? So let's talk about those lower level things. So let's talk about pods and volumes. So what is a pod? As I mentioned, pod is a single unit that gets scheduled in Kubernetes, okay? It can contain a single container, or it can contain multiple containers. This is the case where you want containers to start together and die together. And it can also contain a volume. A volume is basically a pod scope storage that containers can use. So for example, in this case, we have a container called file puller that's pulling some files from some place, and then it's saving them to some volume. And then there's a web server that exposes those files probably to consumers. So we have two containers and a single volume. We put them in a single pod, and these will be scheduled as a unit in Kubernetes. So that's what a pod is. And then as I mentioned, volumes are pod scope storage. So these are the storage that your containers use, but they are scoped for the pod. So if the pod goes away, the storage goes away as well. And they support many types, so you can attach many types of volumes to your pod. So once you have your pods, you can label them, and you can select them as well. So the labels in Kubernetes, they're really important constructs. In every place in Kubernetes, we use labels to access pods. When you create services, for example, you use labels. When you create replica sets, you use labels. So you can attach any kinds of labels to pods. For example, in this case, we have 4 pods, and then we have some labels. Like, so we have the app label that has the my app value, we have the phase label, and then we have the role label. And you can have as many as you want. But then once you have these labels, what you can do is you can access pods using the label. So you can say, give me all the pods with app equals my app. So this will give you all your pods because all of your pods have these labels and this value. So if you want to get your app, but on the front-end pods, you can say, give me all my pods with my app, and then role equals FE, which is front-end. And this will give you only two pods. If you want to get back-end pods, you can do this. If you want to get production pods, you can do that. Or if you want to get test pods, you can do this. So it gives you all this different ways of accessing pods and grouping them together. Yeah, so next let's talk about replication. So there's this construct called replica sets in Kubernetes. So you can think of replica sets as a way for you to, you basically specify the state that you want to be true, and replica sets make that true for you, no matter what. So in this case, for example, we have a replica set with this name, and this is a selector. So this is the label that this replica set will look for in the pods, and this is a template that it will use. And then I'm saying replicas 4. So what this says is that, you know, make sure that I have 4 pods with these labels running all the time. Okay? So that's my wish as an admin. That's what I want to happen. So what replica set will do is that it will basically ask the API server, how many pods do I have right now? If the API server says 3, then it will create 1 more. And then it will ask again, how many do I have? Now it says 4, so it won't create anymore. If at some point you have 5 pods, then it will take 1 away. So basically, you just specify what you want it to be true, and replica sets make that true for you without you having to do anything. So in this case, for example, we are saying, I want 3 pods, and I want my pods with these labels. So my app is demo app, and the color can be either blue or gray. So as you can see, in this case, replica set is managing 3 pods. They all have app equals demo, because that's what I want. And the color, some of them have blue, some of them are gray. So if any of these pods go away, then replica set will create a new pod on a different node and make sure that these constraints that I specified here, they're met. Okay? So let's look at this. Let's look at how this works. So here I am in Cloud Shell again. My pods are running. I have 1 pod. So let's just kill this pod and see what happens. So I'm going to do kubectl, delete, and pass in the pod ID. So this will kill this pod. And then replica set detects this right away. And if I do get pods again, as you can see, I have a new ID. So what happened is that this was really quick. What happened is that replica set realized that I killed the pod, and it created a new pod already and made sure that it's running. So this way, like if something goes wrong with the pods, if the machine goes down or something like that, replica set will detect that right away and create a new one. So that's replication. And then next, I want to talk about services. So as I mentioned, the pods, you can have as many as you want, but how do you access pods, right? So at some point, you want to be able to talk to pods from the client. So the way to access pods is through services. What you can do is you can create a service and say, I want a service that load balances, basically, pods with this label, right? So you use the label to group pods into a service. And then the clients will talk to the service, because the service will have the stable virtual IP. So the client will talk to the service, and the service at random will pick a pod when it gets a request. So you can think of services as kind of like a load balancer for your pods. So let's just create a service for our app, because right now our pods are running. We have a replica set that's running, but no one can access them from outside of the world yet. So let's just make that happen. So here I am again using kubectl. This is my deployment that's running, and then this is the 1 pod that I have running. So now what I want to do is I want to expose this pod in a service. So I'm going to say kubectl expose deployment. This is the name of my deployment. And the type, I'm going to say load balancer. So this basically says create a service that it's basically a load balancer. This way it can be accessed from the outside world. You can also have internal load balancers so that it's only accessible within the cluster. So if I do kubectl get service now, I have my service. It has an internal IP, but the external IP is pending because it takes a while for Google Cloud to create a load balancer and get that up and running and then attach that to the cluster. So we have to wait a little bit for the external IP of our service. So let's just fast forward so we don't have to wait. So at some point we're going to have external IP. It should be somewhere here. It's pretty quick. It takes like 1 or 2 minutes. So if you do kubectl get service, now we have an external IP, and we can use that external IP from the browser. And this, if we hit that IP, it will basically route us to a pod. And remember, our pod is running our microservice. So this will run the same app that we've seen before, but instead of running on my machine or instead of running on my machine in a container, it's now running in Kubernetes in Google Cloud. And we were able to reach it because we created a service for it. Okay. All right. I have a little bit more time, so let me just go through this quickly. So these are services. Now let's talk about scaling. So let's say you have a replica set with 3 pods running with this version and with this type front end, and they're being serviced by a service. Again, it's using, by the way, this type should be FE. This is wrong because that's what it is serving. I'll change that. So let's say you want to increase the number of pods from 3 to 4. What can you do? You basically just change the number of pods in your replica set to 4, and replica set scales it for you. So you don't have to worry about machines, or you don't have to worry about anything, basically. Just tell replica set, just give me 4 pods. I don't care where you do it, how you do it, just do it, and it will do it. And then since it has the same label as before, the service will pick it up and load balance it to that pod right away. So let's look at that. Let's see how we scale our app. So here I am again in Cloud Shell. Let's look at our pods. I have 1 pod running right now. I want to scale this to, say, 2 pods. So what I'm going to do is I'm going to say it's kubectl scale deployment hello.net. That's the name of my deployment. And I'm going to say replicas equals 2. So this will basically tell replica set scale to 2. And right away, we have 2 pods running. If I want to scale to 3, I just change replicas to 3. And right away, I have 3 pods. And you realize how fast things work. Like you have pods scheduled right away. If I want to scale down back to 1, I can change it to 1, and now we scale down. So that's how scaling up and scaling down works. You don't have to write scripts. You don't have to worry about yourself. You just tell Kubernetes scale up, scale down, and it does it for you. All right. So that's scaling. Rolling updates. So this is probably my favorite topic. When you have this setup, so for example, I have my app version 1, and I have replicas. So I have 3 pods running with these selectors, okay? And then I also expose these 3 pods through a service. So I have them exposed through the service. Let's say I want to introduce a new version of my application. I want to introduce version 2. The proper way of doing that is as follows. So first, one way you can do is because you can kill everything and create a new one and just route everything there, but that's not rolling update, and that's not the proper way. The proper way is this. First, you create a new replica set with the version 2, and then you create a pod, just 1 pod there, and add it to your service. So now your service load balances between 3 old nodes, pods, and 1 new pod. Then once things are working, you take one of these guys out. Then you create another one here. And then you take one of these guys out. And then you create another new one. And you take the other one out. And if everything is working, you get rid of the replica set, and now you have your service just serving the new traffic, right? So this is what you should do. And if you have to do this yourself, you need to script this. You need to make sure that things are working. And if at some point things are not working, you need to roll back, right? Thankfully, Kubernetes handles all of this for you, so you don't have to do this yourself. And I'm going to show you in the demo how to do that. But before I do that, I want to talk about canary deployments. So what you can do in Kubernetes is, say you have this replica set that's that has these 2 pods that are being served by the service, and you want to introduce a new version. So you can create a new replica set with version 2, and then have that pod running, and you can have service served to those 3 pods. Because remember, the service just looks at the label, right? So the label here is BE, and all of these pods have BE. Now, some of these pods have version 1, and some of them have version 2, but the service doesn't care. So it only cares about the type BE. So as long as you have the same types for all pods, you can introduce a new pod with the new version and do what's called a canary deployment. This way you can make sure that your new version is working in the environment, and if everything is good, you can decrease the size of the pod here, and you can increase it here, and things work. So that's canary. And then you can also do auto-scaling. So you can tell replica set, I want this number of pods, but I want to make sure that the CPU target is 50% or less, okay? And what you can do is you can install something called Heapster. Heapster basically keeps track of all the CPUs on different pods, and then Heapster will report to replica set and say, oh, by the way, right now the CPU average is 60%. In that case, replica set will create a new pod to bring the average down. So doing auto-scaling is really easy with replica sets. So let me show you the rolling updates. So how do you update your application with Kubernetes? And I think I have like 5 minutes. So here I am. I have my app. And what I want to do is I want to just change one of the index files, so the main page, and update my app to use this new index file. So I already changed this file. It says learn how to build ASP.NET apps that can run anywhere. I changed that to that can run on Google Cloud. So this is my change. So this is my new version. What I need to do first is I need to publish my app. So I'm going to do .NET publish release. So this will get my app and all of its dependencies into a single DLL. Once that's done, we need to build a new image with the new version number. And then we need to push that image to Google Cloud. And then we're going to tell Kubernetes, can you please update and use this new version? So this is building the DLL. And we'll go to the publish folder. And then we're going to build our image. This time, I'm going to use the same tag as before, except instead of using version 1, I'm going to call this version 2, because this is the second version of my app. So this builds the image. This time it's quite fast because we only changed one file, so it figures out the diff. And if I look at my images, I have the version 1 and I have the version 2 that I want to use. Now I need to push this to Google Cloud so I can use it. So I'm going to use gcloud for that. So I'm going to say gcloud docker push and just point to my image. So this is pushing everything, and as you can realize, it says some layers exist, so it knows that some of the things didn't change, so it only pushed the difference. So it's going to be faster than before. And that's why I like containers, because you can do stuff like this. In a virtual machine, this would be difficult. So now what we're going to do is we're going to use kubectl and say edit deployment and give our deployment name, so hello.net. So when we deployed the deployment, it has a YAML file that defines the deployment. So all I'm doing here is going to the YAML file and finding the place where it points to the image. So the image that it points to is version 1. I'm just going to change it to version 2. So that's all it takes to do a rolling update. And when I hit save, now I save this, this will basically go, the rolling update procedure that I showed you, it will do that under the covers. Now I don't have to worry about that. Now I'm going at the service and updating my service. Let's see if I have my update. So as you can see, I have my update already. So it already happened. So all the steps that I talked to you about, it already happened behind the scenes. I didn't have to do any of that. It just happened. All right. And let's see what else I have. All right, so I don't have time, but just to let you know, there are more stuff. There are daemon sets. So these are basically, you basically run a pod on every node. So that's what daemon sets are for. There are jobs. So these are pods that run to completion. And then when they're done, they're killed. So they're good for batch processing. There are stateful sets. So these are pods that have some kind of state. Because the pods that we've seen so far, they don't have any kind of state. But in some cases, if you want to run like a SQL server or something, you need a state. So these stateful sets kind of help for that. And there are config maps. So you can define the configuration of your app at a central place. And then when your pods are created, a volume gets attached that has this config map that you can use. So this is good for configuration. And then if you have secrets, you can define them in a central place. And then when your pod gets created, it creates a volume with the secrets. And there's more. I just basically scratched the surface of this. But if you want to learn more, go to kubernetes.io. It has much more documentation and samples. If you want to run Kubernetes on Container Engine, that's the link. And as I mentioned, if you want the slides, I'm going to post it on Twitter. Thanks for your time. I have some stickers of Kubernetes and Google Cloud. If you want them, come and get them. So thank you very much.